everyone, thank you so much for clicking onto the video. Today's learning objective is to understand the following techniques used in the preparation and purification of a liquid organic compound. So we're going to look at heating under reflux, extraction with a solvent in a separating funnel, distillation, drying with an anhydrous salt, and also boiling temperature determination. So now we're going to talk about oxidizing a primary alcohol. So first we're going to discuss oxidizing it to an aldehyde. So we use a dilute sulfuric acid and less potassium dichromate than is needed for complete oxidation to carboxylic acid. And so these are the two conditions that we need to remember, is that we're using dilute acid and also not very much of the oxidizing agent. And then the mixture is heated gently in distillation apparatus. So it's like the diagram on the right, but instead of having the mixture containing water, ethanoic acid, and inorganic residues, we would have the primary alcohol and the dilute sulfuric acid and the oxidizing agent. One really important thing to know is that the receiver is cooled in ice, and this is to reduce evaporation of the ethanol. And this is because ethanol's boiling point is extremely low at around 21 degrees Celsius. So actually less than room temperature, and that's why we need to keep the receiver in some ice. And because ethanol has a very low boiling point, it vaporizes as soon as it's formed and distills off. And this stops it from being oxidized further to ethanoic acid. Now looking at oxidizing a primary alcohol to carboxylic acid. This time we use concentrated sulfuric acid and also an excess of this oxidizing agent. And the mixture is refluxed. And what we mean by reflux is that, like the diagram on the left, we have the ethanol and the excess of oxidizing agent and concentrated acid. And what happens is that it gets heated and the vapor goes up the condenser tube, but this time it's straight up. And so what happens is that because there's cold water which is being fed in to the bottom of the tube and out at the top, it condenses the vapor. And so this vapor then drips back into the pear-shaped flask because the condenser is straight on top of it. And so this means that any ethanol or ethanol vapor will condense and drip back into the flask until it is all oxidized to the carboxylic acid that we want. And reflux is a really important experimental process that you should remember. And after refluxing for around 20 minutes, we then distill off the ethanoic acid along with any water using the apparatus on the right. So kind of like how we did the oxidation of the primary alcohol to the aldehyde. So if we wanted to write some equations using the symbol for oxidation, and we used, let's say, ethene, ethanol as an example, what we would get is to oxidize the ethanol to the ethanol, we would have CH3, CH2OH, which is the ethanol, and then you'd have to have this square bracket O, which indicates that you're oxidizing it, and then you'd form the ethanol and also water, where this ethanol is a gas and the water and the ethanol are liquids. And then to oxidize the ethanol into ethanoic acid, what you'd have to have would be the ethanol, again a liquid, but this time you'd have to have 2 times this square bracket with the O, because we're using double as much of the oxidizing agent, and this will form our ethanoic acid. And so a key takeaway is that when we use these kinds of equations with the square bracket O, we have to balance the equations as well, because we see that we have 3 oxygens on the left and we have 3 oxygens on the right. So it wouldn't work if we only had 1 square bracket O, because we need to balance the equation. Now we're going to have a look at purifying an organic liquid. So the overall method is that firstly we put the distillate of impure product into a separating funnel. The distillate is what we've just got from the distillation. So it's the liquid that we've just collected. And then the second step is to wash this product by either adding sodium hydrogen carbonate solution and shaking it and releasing the pressure from carbon dioxide produced, or we add saturated sodium chloride solution. We then allow the layers to separate in the funnel and then run and discard the aqueous layer. We then run the organic layer into a clean, dry conical flask and add 3 spatula loads of drying agent, which we're using anhydrous sodium sulfate, and this will dry the organic liquid. We then carefully decant the liquid into the distillation flask, and decant just is a fancy word for filter. And the last step is to distill to collect a pure product. A really important note is that the drying agent that we choose should be insoluble in the organic liquid and not react with this organic liquid. And another thing to think about is that the sodium hydrogen carbonate will neutralize any remaining reactant acid, and sodium chloride will help separate the organic layer from the aqueous layer. Now we're going to look at how to extract solvents. So the first thing you do is mix the organic solvent and oil water mixture in a separating funnel like the one on the right. And then you distill to separate the oil from the organic solvent. And then we add anhydrous calcium chloride to clove oil to dry the oil. And then we decant to remove the added calcium chloride. Now I'm going to talk about measuring the boiling point. So the purity of a liquid can actually be determined by measuring its boiling point. And this can be done in a distillation setup or by simply boiling a tube of the sample in a water bath. So in this diagram, we've got a beaker with some water that we're heating up. So this will act as the water bath. And to get a correct measure of the boiling point, the thermometer should be above the level of the surface of the boiling liquid and also be measuring the temperature of the saturated vapor. Pressure should be noted, as changing the pressure can change the boiling point of a liquid. And also measuring the boiling point is not the most accurate method of identifying a substance, as several substances may have the same boiling point. Now, the reason why the purity of a liquid can be determined by measuring its boiling point is that if it's 100% pure, it should have a very sharp boiling point. And so it should all vaporize at the exact same time at the same temperature, which isn't the case most of the time. But if it's 100% pure, then it should do that.